Hello everyone. Today we are again together for a new session. Today we will discuss the important topic which is manipulation of gaseous molecule, and we will discuss here the collision between the gaseous molecule, how they collide with each other, and we also discuss the collision frequency, collision diameter, collision cross section, and further we will discuss the collision frequency of these molecule for the homogeneous molecule and heterogeneous molecule. So we start from the introduction of collision of gaseous molecules. According to kinetic theory of the gases molecule are collide always in random motion, so they can collide with each other and collide with the walls of containers. So but the collision should be elastic. These are elastic body, and these body also in spherical form, rigid form, and non-interacting body. So if we talk about their collision per second suffer by individual molecule referred to a collision frequency which is denoted by Z, then the collision frequency of a gas molecule which is equal to number of collision divided by total time taken for this collision. And for example, we consider these two molecules. One is M molecule and other is N molecule. They collide with each other, and their distance between their center is sigma, which is collision diameter, and it is denoted by sigma. And collision diameter is equal to sigma m, radius of molecule m plus radius of molecule n divided by 2, which is equal to the collision diameter. Uh, and further, we if we talk about the sphere of influence or collision cross section, which will be equal to the pi sigma square. And if we talk about the volume of sphere of influence, which is equal to 4 pi E3 4 by 3 pi sigma cube. So for the homogeneous collision, we can assume that one molecule of a gas is moving and rest are in stationary form in homogeneous collision with the average speed of Ca in unit time. A particular molecular cover of a velocity Ca, and which is travel from position from A to B. So they collide all the molecule whose center fall within the sphere of influence. So we can say that the colliding space swept by a single molecule in a unit time, which is equal to their area and distance covered in unit time, which is actually equal to its velocity. So the final relation will be equal to the area multiplied by velocity. Area is equal to pi sigma square, which is multiplied by velocity. Velocity is Ca. So let's suppose that n is the number of stationary molecule per unit volume, and the total number of molecule within the volume pi sigma square Ca into n, which is n number of molecules, which is equal to the number of collision by a single molecule per unit time, which is actually called frequency, and which is also equal to the volume multiplied by number of stationary molecules. Volume is pi sigma square Ca, and n is a number of stationary molecule n. And however, it is not to have a other gases molecule or stationary. Actually, they are all in motion, and many experience of the following three type of the collision. It may be a head to head collision, and here the collision angle is 180, and glancing or crazy collision, which is where collision angle is at 0, and other is a right angle collision where the collision angle is 90. They collide with each other, but an average perpendicular head to head on collision and the right angle collision, the average collision perpendicular at 90, which is taken into its consideration. However, the average velocity is equal to Ca square plus Ca square under root, which is equal to 2 under root Ca. Now, for the more accurate estimation, the value of CCA in equation second can be replaced with the relative velocity, which is 2 under root CA. Thus, the number of collision by a single molecule per unit time, which is equal to 2 under root pi sigma square CAN. And luckily the number of collisions suffered by n molecule per unit time, which is this equation will be multiplied by n, because n number of molecule are collide with suffer by a n molecule. That collision suffered by a n molecule, then one n also multiply with this above equation. Further, we just make this relation. This will be n square, and then we have added the value of average velocity, which is equal to 8 RT over pi m, where m is a molar mass, r is a gas constant, t is the absolute temperature. Then the equation become into that form. So in this equation we just change one thing. We have solved this 8 under root, and which is going to be 2 into 2 under root. Then the final equation for the collision frequency, which is equal to 2 n square sigma square pi RT over m. So this is collision frequency. Then from this equation we can derive some relation, which is equal to that is proportional to sigma square, which is that is also proportional to the n square, also proportional to the t under root, and also proportional to the 1 over m. Here is Z is a collision frequency, sigma is a radius of that colliding molecule, and N is a number of molecule number of molecule which are collide with each other, and T is a absolute temperature, and M is a molar mass of a gas molecule. So this is about the collision of gaseous molecule for homogeneous collision. We are meet together for a next session for the collision of gaseous molecule, especially for the heterogeneous collision of a gaseous molecule.